So what if I told you there's this one single rule that runs everything? I mean, from the tiniest spark in your brain to a star blowing up across the galaxy. It's so basic, so fundamental that without it, the universe as we know it just couldn't exist. Today, we're going to get into exactly why energy can't be destroyed.
I mean, think about it for a second. You've seen this happen a million times, right? You pour a hot cup of coffee, and before you know it, it's cold. A ball you're bouncing just stops. A campfire burns down to embers. In all these situations, it really feels like the energy just disappears. Poof, gone. So the big question is, where does it actually go?
Well, here's the crazy part. The answer is super simple, but also kind of profound. It doesn't go anywhere. It's all still there. It's just wearing a different costume. It's changed its form. And that's the core idea we're going to unpack. Energy never, ever gets destroyed. It only gets transformed.
All right, Section 1, the universe's unbreakable rule. You can think of it as the currency of nature. And to really get this, we have to start thinking of energy as exactly that, the universe's cash. It's what pays for every single thing that happens, every action, every reaction, from the microscopic all the way up to the cosmic.
So yeah, it's not some substance just floating around out there. It's much more fundamental. It's like the thread that's weaving the entire fabric of reality together. You know, it's the go and get up and go. It's the force that makes anything and everything possible.
Okay, let's make this real with some examples you see all the time. That hot coffee, its heat doesn't just disappear. Nope, it transfers that energy to the air molecules all around it, making the air just a little bit warmer. Or a pendulum. All that stored up energy at the top of the swing gets converted into raw motion at the bottom. And the wood in a campfire, that's just chemical energy waiting to be released as heat and light. You see the pattern here? In every single case, the energy account is perfectly balanced. Nothing is ever lost.
Okay, so now we're moving on to a secret of time, the deeper reason behind this whole rule. Because look, it's one thing to say energy is conserved. Fine. But the really cool question is, why? Why does the universe even have this unbreakable rule? And the answer, believe it or not, has everything to do with time itself.
Now, you probably remember this from science class, right? The first law of thermodynamics. It's the official rulebook version. In a closed system, the total amount of energy stays the same. And that's a perfect description of what happens. But it doesn't really tell us why it happens. It's a rule, not a reason.
So yeah, we have to dig deeper. Why is this even a law? What's the fundamental principle that makes it true? What is forcing the universe to be such a strict bookkeeper with its energy? And the answer is this beautifully simple concept called time translation symmetry. Okay, sounds fancy, but all it really means is that the laws of physics are the same no matter when you test them. They're the same today as they were yesterday, and they'll be the same tomorrow. Gravity works the same way on Tuesday as it does on Saturday. The rules just don't change. And here is the absolute genius connection, thanks to a mathematician named Emmy Noether. She figured out that for every one of these deep symmetries in the universe, there's a conservation law that goes with it. It's a perfect pairing. So, because the laws of physics don't change over time, because of time symmetry, energy has to be conserved. It's not just a good idea, it's a mathematical necessity. It's baked right into the fabric of time.
All right, part 3. Energy's many disguises, from atoms to galaxies. Now that we have that incredible why in our back pocket, let's have some fun and look at all the different costumes energy wears across the universe.
Let's go back to our trusty pendulum, because it shows this exchange so perfectly. When it's way up at the highest point, it stops for a split second, right? That's when all its energy is potential. It's just stored up, waiting. Then, as it swings down, that potential energy converts into kinetic energy, the energy of motion. It's going fastest at the very bottom. It's this perfect dance, a constant trade-off between stored energy and motion energy. The total amount stays exactly the same.
And this isn't just for swinging objects. It's the story of life itself. It all starts with the sun, right? Its light energy travels all the way to Earth. A plant grabs that energy through photosynthesis. Then an animal comes along and eats the plant, taking that energy for itself. And when that animal's life is over, decomposers release that energy back into the whole system. It's just one long, continuous chain, with energy changing hands over and over, but never, ever leaving the game.
And of course, we have to talk about maybe the most famous disguise of them all. E equals mc squared. We've all seen it. What Einstein showed us is that mass itself is just another form of energy, a super concentrated form.
That c squared is the speed of light squared, which is just a ridiculously huge number, so it tells you that even a tiny, tiny bit of mass can be converted into an absolutely massive amount of energy. The books are always balanced.
And you know what? This rule holds up even in the wildest, weirdest corners of the universe. Down at the quantum level, particles can actually borrow energy from nothingness as long as they pay it back almost instantly. When matter meets antimatter, they annihilate each other, converting their mass perfectly back into pure energy. And get this, the energy from the Big Bang itself, it's still with us. It's just been stretched out and cooled down over billions of years into what we now see as the cosmic microwave background. It's the echo of creation, and every bit of that original energy is still accounted for.
Okay, final section, a universe built on conservation. And this is all about why it matters. Because this is not just some abstract idea for physicists to debate. The conservation of energy is the absolute bedrock of our reality. It's the reason we live in a stable, predictable universe at all.
I mean, really think about what would happen without it. Cause and effect, that would go right out the window. All the laws of motion we rely on, totally meaningless. The very atoms that make you up couldn't hold together if their energy could just pop out of existence for no reason. And life itself, which is basically just a very elegant, complex way of processing energy, would be completely, utterly impossible. It's the ultimate foundation of stability.
There's a great way to think about this. In the grand symphony of existence, energy is the melody that never stops playing, only shifting from one instrument to another. It's such a beautiful image, right? The song of the universe just keeps going forever.
Which, of course, leaves us with one final, absolutely mind-bending question to chew on. If no energy is ever lost, if it can't be created or destroyed, then where did all of it come from in the first place? And that's a question that takes us all the way back to the very beginning of everything.